Solutions, very important topic. Just remember that the majority of chemistry occurs in solution. Your body is made up of solutions. Blood is the biggest example. Your cells inside them and outside them have solutions. And solutions are needed to carry out many, many functions. Otherwise, life would not be possible without solutions. It's as simple as that, especially in the liquid phase. So the other name for solutions is homogeneous mixtures. And in order for you to have a solution, you need two parts. And that is a solute, the minority substance, meaning this is what's used to be dissolved in solution, and the solvent, this is the majority substance, this is the substance that's needed to dissolve the solute. So an example of this is Kool-Aid. Simple as that. Water would be your solvent. And the Kool-Aid, which is made up of sugar, colorings, etc., all of that, these would be your solutes, or let's say the solute. Water is the most important solvent. As I said, life, biochemistry occurs in water, in what we call aqueous solutions. And in aqueous solutions, which is shorthand is AQ, that's aqueous or aqueous, is a solution in which water is a solvent. It comes from aqua. This is important for this subscript. So if you have anytime you have this example, NaClS versus NaCl AQ, this should not be dismissed. You probably know the difference. This would be solid salt, and this would be salt water in a layman terms, or a salt solution. Saline solution, they call it in the hospitals. So again, this is important to realize. Now, a quick introduction to solutions that involve table salt and, in this case, sugar. What occurs to us on the macroscopic level, like when you go to the kitchen and you dissolve salt in water to gargle with for bacterial infection, whatever it is, or if you dissolve sugar in water to make some kind of a drink, what we see is really not that interesting. I mean, we just see a solid dissolved in solution, but the chemistry is very involved. What happens at this level is that when salt is dissolved, it breaks up into the individual ions. So if you see the plus here and you see the minus, so you should know which one is the plus, which one is the minus. Yes, the plus is Na, so that's Na plus, and of course the Cl is the minus. So this should tell you what kind of a compound is this. Is it an ionic or molecular compound? So it's an ionic compound. What happens in here is that once salt is dissolved in water, the sodium, for educational purposes, let's say here is the plus and here is the minus. So there is a bond between them called an ionic bond. They're attached to each other. They're not dispersed. Once you put them in water, water simply disperses them. So it breaks them apart and prevents them from recombining. And in this case, what happens is you end up with a negative and a positive dispersed throughout the water. That's what a solution is. There's an interesting thing about this. This is not just ions floating around, is that if you try to measure whether it conducts electricity, it will conduct electricity because you have ions here that carry the charge and allow for the electric current to move throughout. This again might sound to you like it's far-fetched. I have nothing to do with that. Your body is really this happening, right? You have ions inside the cells. In and outside, you have sodium and chloride, you have potassium. All of this is, again, contributing to the chemistry and creating electricity to power your cells. So if I were to write this down, it would be NaCl, aqueous, after it's dissolved in water, and of course it breaks into Na plus and Cl minus. A few things to say about this is that the ions carry the charge, and of course, this is very important. By the way, let's put the AQ here in a different color. Is that this solution conducts electricity. So it conducts electricity. Whereas if we go back to the sugar solution, what is happening here is that you have a molecular compound. All of those are nonmetals. So if you have sugar that's breaking down, it's still C6H12O6, and it's neutral. There is no charge on it. Neutral. There's no charge. So in this case, if I have sugar right here, C6H12O6 as a solid, or as, if I start with that, this is going to become simply aqueous, which means it's dissolved in water. So in this case, what you have is you have a neutral solution. There are no charges. So we say here that this is neutral molecules. And of course, it does not conduct electricity. So where do you think then these names come from? Electrolytes and non-electrolytes. They come from this idea in chemistry and solutions. So electrolytes are substances that dissociate into ions. This is the key. And of course, once you have ions, you can conduct electricity. So you must have ions in order for the solution to conduct electricity. The charge helps those electrons move around in a sense. What are electrolytes? Electrolytes are ionic compounds. So there's a cation and an anion. So we just gave you a primary example. Table salt has Na plus and Cl minus. You can have any ionic compound, such as, let's say, calcium carbonate, which is limestone used in chalk. So Ca plus 2, CO3 minus 2. So again, cation and an anion, positive and negative. Acids are considered electrolytes, like stomach acid. Acids are defined as substances, you might have heard of this before, at this point, is that they are substances that produce H plus ions in solution. So H plus we call it a hydrogen ion, or it would be better if you remember this. It's called simply a proton. It is a proton. It's lost one of its only electron, so it's left with a proton. You can check that on the periodic table. So it produces protons or H plus ions in solution. So what's an example? Here's a stomach acid. This is H plus and Cl minus, hydrochloric acid. You might have said, oh, we just talked about, ionic compounds. That's why I was very, very, very careful in saying it's cations and anions. Of course, it is mostly metals and nonmetals, but in this case, you have both nonmetals. However, it's an acid, so it's considered an electrolyte because it does actually break apart due to the difference of electronegativity, if you remember what that is from previous classes, but we will examine that later. Also, you have sulfuric acid used in industry a lot. So you have H plus, you have two of them, plus SO4 minus 2. Bases, on the other hand, so one way before we get to bases, one way of remembering what acids are is that, again, they start with an H, and again, they end with an AQ, so that indicates that it's an acid. Bases are substances that produce OH minus ions in solution as a simple definition. Well, here's an example. Sodium hydroxide. So this is called Lye, L-Y-E. It's used a lot in the industry. And again, this is what it produces. So I like to circle each component. This is your base. And that's what that acid does. So again, look for anything that ends with an OH. These are bases. And they neutralize, of course, the acids. Now, non-electrolytes, on the other hand, are substances that do not dissociate into ions in solution and thus do not conduct electricity. Examples of these are the sugars. So if you have something like C6H12O6, that's glucose, etc. Again, these are molecular compounds and they do not dissociate. So understand, the formula of sugars is always C, H, and O, like that. Of course, usually, again, at least it starts with a 5, and then whatever follows afterward. So again, these are sugars. Alcohols do not dissociate either. They are simply, they usually have this formula like this. They have a CH and then it ends with an OH. So you have a CX, HY, and then OH. So for example, CH3OH, this is methyl alcohol or methanol, very toxic substance. You also have something like ethanol. So you will have C2H5OH, or sometimes it's written in another way, but here it is. This is ethanol. So all of those are non-electrolytes. And of course, you have neutral covalent molecular compounds that do not dissociate, just like the sugar. So those are usually lipids and oils. Those do not dissociate.